Alright, this is the second part where it kind of corresponds to the second page of the first exam for pre-cal. We're going to go through some commonly missed problems on the second exam. So we're going to go ahead and look at the first one, which was number 7, and it's the absolute value of x squared plus 10x is equal to 9. Okay, so absolute value is the distance from 0, so we can have two possibilities. We can have one for the positive direction, one for the negative direction. So that means we drop the bars, and we either have x squared plus 10x is equal to 9, or x squared plus 10x is equal to negative 9. Okay, from there, these are both quadratics. We're going to set them equal to 0 and cross our fingers that they factor. So one of them is x squared plus 10x minus 9 equals 0, and I don't think I'm going to factor that one. Or x squared plus 10x plus 9 equals to 0, and I think that one I can factor. Okay. So for problem the first one, I can either do quadratic formula or complete the square. We'll just go ahead and do the quadratic formula. So it's going to be negative 10 plus or minus the square root of 10 squared minus 4 times 1 times negative 9, all over 2 times 1. So this is negative 10 plus or minus the square root of 136, and 136 is 4 times 34. Negative 10 plus or minus 4 root 34, or square root of 4 and 34. Divide the 10 by 2 and get negative 5. The square root of 4 is 2, and then we divide it by the 2's. We just left with square root of 34. Lucky for us, the other one does factor, and that factors into x plus 9 and x plus 1. So then that gives us the other two solutions of negative 9 and negative 1. Okay. The other version of the exam has something very similar, where one version will factor and the other version you're going to have to use the quadratic formula. Okay. So moving along to problem number 8. On one version is 3 plus the square root of 3x plus 1 equals x. And how we solve these radical equations is we had to isolate the radical. So what we're going to do first is we're going to subtract 3 from both sides. And we have the square root of 3x plus 1 equals x minus 3. To undo this square root, we will square. So we'll square both sides. And we have 3x plus 1 is equal to, then we'll have to FOIL it out, x squared minus 6x plus 9. So this is quadratic, so we're going to set it equal to 0, and we're going to hope it factors. So if 0 is equal to x squared minus 9x plus 8, we'll go ahead and factor that into x minus 8 and x minus 1. And then that gives us answers of 8 and 1. Now when I plug 8 in, 8's going to work out in the original equation at the top there, but the 1's not going to be an extraneous solution, so we're going to throw that one out. So we just have one good answer. Okay, we're going to look at two other commonly missed problems on this exam. Number 9 was the absolute value of 2x plus 7 is greater than 4. So that needs to be further off to the right of 4 or further off to the left of negative 4. So that distance is greater than 4. So on one hand we just drop the absolute value bars, or we drop the absolute value bars but we want to be further off to the left of negative 4. So they'll be less than negative 4. So solve these both in the same way. We'll subtract 7 for both sides. So 2x is greater than negative 3. Or 2x is less than negative 11. We'll divide both sides of both inequalities by 2. X is greater than negative 3 halves, or x is less than negative 11 over 2, or negative 11 halves. Writing our intervals, the right interval inequality here gives us this one, and the other inequality gives us this part of the interval. Okay. So where you would have seen this first is in Matho 306, if you did take that class with us. Okay, we're going to look at one other one that is really just a college algebra problem. So you have 2x plus 7 over x minus 2 is less than or equal to 0. Our boundary points are where the top and the bottom equals to 0, so those boundary points are going to be negative 7 halves and positive 2. Since 2 is a restriction, we put it in the denominator and we get a 0. We're not going to have a bracket at 2. Okay. So then what we do from there is we're going to make our sign chart, put in minus infinity, our boundary point of negative 7 halves, and our other boundary point of 2. Gives us negative 10, 0, and 10 as some test points. Testing 10 does not work. Testing negative 10 does not work, because you'll have a positive divided by a positive, which is not negative, because of the inequality says less than or equal to. We don't want positive, so plugging in negative 10 and 10 will get positive. When we plug in 0, we're going to get a negative. Okay, because we have less than or equal to, we're going to have a bracket, but only at negative 7 halves. 2 is a restriction. Okay.